Imagine you're sitting on a high-speed train cruising at 250 kilometers per hour. You're 78 meters below the ocean floor. That's about as deep as a 25-story building is tall. Above you, cargo ships are crossing one of the world's busiest shipping lanes. The water pressure at this depth could crush a car like a tin can. And you're casually scrolling your phone, eating a sandwich, completely unbothered. Sounds absolutely insane, right? Like something out of a futuristic movie where humanity has conquered the impossible. Well, it's not fiction. It's happening right now in China. They're building an undersea tunnel so extreme, so technically insane, that when it opens in 2028, it'll shatter every record we have for underwater rail construction. We're talking about the Jintang Undersea Tunnel, over 16 kilometers long with more than 11 kilometers of it carved directly beneath the seabed. To put that in perspective, that's longer than the distance most people drive to work. Except this commute involves two massive tunnel boring machines, the size of apartment buildings meeting up deep underground, with the precision of a surgeon's scalpel. And here's the kicker. They're doing it at speeds and scales that make other countries' underwater tunnels look like practice runs. Today, we're diving deep into how China pulled off what many engineers thought was borderline impossible. The mind-bending precision required to connect two tunnels under the ocean, and why this project might be the blueprint for something even bigger, a tunnel across the Taiwan Strait. Before we get into the madness, make sure you hit that subscribe button and turn on notifications so you don't miss any of our upcoming videos. Trust me, you're going to want to see what comes next. Why build a tunnel under the ocean in the first place? Okay, so before we talk about how they're doing this, let's talk about why. Because honestly, building a tunnel under the ocean sounds like the kind of idea someone pitches after one too many energy drinks. Here's the situation. Zhoushan is a cluster of islands off the coast of eastern China. Beautiful place, fishing villages, beaches, one of the country's biggest offshore petrochemical bases. But here's the problem. No trains, zero. If you wanted to get there from the mainland, you either took a ferry or drove across a series of bridges. And while bridges are cool, they're not exactly efficient when you're trying to move millions of people and tons of cargo quickly. China's solution: build a high-speed rail line that goes under the ocean. Now you might be thinking, why not just build another bridge? Great question. Bridges have limitations. They take up space on the surface. They can disrupt shipping lanes, and in some areas, the water is just too deep or too rough to make them practical. Tunnels, on the other hand, can go anywhere. They don't care about waves, storms, or ships passing overhead. They're the ultimate cheat code for connecting places that seem impossible to reach. And China's been on a mission to connect everything. Over the last decade, they've built 45,000 kilometers of high-speed rail, more than the rest of the world combined. They've mastered bridges, viaducts, and mountain tunnels. The ocean was the final boss level, so they decided to build the Jintang Undersea Tunnel. And when I say build, I mean they went all in. This isn't just any tunnel. It's designed for high-speed trains traveling at 250 kilometers per hour. That's faster than most cars on a highway. And it's happening 78 meters below sea level in one of the most geologically complicated areas you can imagine. Which brings us to the next question. How do you even start building something like this? Meet the machines. 30,000-ton beasts that eat through rock. All right, let's talk about the stars of the show, the tunnel boring machines. And no, these aren't your average construction vehicles. These things are absolute monsters. The two machines used for the Jintang Tunnel are named Dinghai and Yongzhou. Each one is about 150 meters long. That's half the length of the Eiffel Tower lying on its side. The cutter head alone, the giant spinning disc at the front that actually digs through the Earth, is nearly 15 meters across. Imagine a circular saw the size of a 5-story building, spinning with enough force to slice through solid rock like it's butter. These machines weigh around 4,000 tons each, about the same as 8 fully loaded Boeing 747 jets. And they don't just dig, they're fully automated engineering marvels. As the cutter head grinds forward, the machine simultaneously removes debris, installs reinforced concrete rings to support the tunnel walls, and injects grout to seal everything in place. It's like building a skyscraper horizontally underground in real time. But here's where it gets wild. These machines have to deal with something called mixed geology. Along the tunnel route, the ground isn't consistent. One minute you're boring through solid granite, hard, stable, predictable. The next minute, you hit soft clay or sandy soil that can shift and collapse if you're not careful. Over the course of the tunnel, the machines encounter 28 different geological transitions. 28 times they have to adjust their speed, pressure, and cutting technique to avoid disaster. To handle this, Chinese engineers made custom modifications. They added water injection systems to the cutter head to deal with sticky clay that could clog the blades. They reinforced the sealing systems to withstand the crushing water pressure at 78 meters below sea level. And they upgraded the drive systems to ensure these machines could run non-stop for months without breaking down. Now you might be wondering, okay, so they've got two of these machines. How do they work together? That's the genius part. One machine, Yangzhou, starts digging from the Ningbo side, the mainland. It digs nearly 5,000 meters. The other machine, Dinghai, starts from the Zhoushan side, the island. It digs over 6,000 meters, and somewhere in the middle, deep under the ocean, they're supposed to meet. But here's the thing. They can't just eyeball it and hope for the best. If these two machines miss each other by even a few meters, you don't have a tunnel. You have two separate holes in the ground that go nowhere. And at that point, you've just spent billions of dollars on the world's most expensive failure. The millimeter game. How do you connect two tunnels under the ocean? Okay, so imagine you're trying to thread a needle, except the needle is 15 meters wide. It's buried 78 meters below the ocean floor, and you're guiding it from over 6 kilometers away. Oh, and if you miss, you've wasted years of work and enough money to fund a small country's infrastructure budget. That's basically what China had to do with the Jintang Tunnel. The challenge here is precision. When you're digging a tunnel from both ends, even the tiniest error in angle or alignment compounds over distance. A deviation of just 1 degree at the starting point could mean you're dozens of meters off target by the time you reach the middle. And underwater, you can't exactly stop and measure things with a tape measure. So, how did they solve this? 2 words: Beidou satellites. Beidou is China's answer to GPS, a network of navigation satellites that provides positioning data with incredible accuracy. But here's the thing. Traditional satellite positioning can be off by a few meters, which is fine if you're driving a car, but completely useless if you're trying to connect 2 tunnel boring machines underground. So, Chinese engineers took it a step further. They deployed 6 Beidou satellites specifically for this project and linked them directly to the auto navigation systems on both tunnel boring machines. These systems constantly track the machine's positions in 3-dimensional space, latitude, longitude, and depth, and make micro adjustments in real time. Think of it like this. Every few meters, the machines send a signal to the satellites. The satellites calculate exactly where they are, compare it to the planned route, and send corrections back. If the machine is drifting even a centimeter off course, the system adjusts the cutter head angle and steering to bring it back in line. It's like having a GPS that's accurate to within 2 centimeters, guiding a 4,000-ton machine through solid rock. And it worked. When Dinghai and Yangzhou finally met deep under the seabed, the alignment error was less than 2 centimeters. 2 centimeters on a tunnel that's over 11 kilometers long. That's the equivalent of threading a needle from across a football field. The ultimate sacrifice when machines become part of the tunnel. All right, so you've got 2 massive tunnel boring machines that just met up deep under the ocean. They did their job perfectly. High fives all around. But now you've got a problem. These things are stuck. There's no way to drive them out, and there's definitely no way to lift them back to the surface. So, what do? You leave them there. Well, kind of. Chinese engineers use a technique called shedding the shell. It's exactly what it sounds like. The machines are carefully dismantled piece by piece from the inside. The drive systems, the cutter heads, the hydraulic components. All the expensive reusable parts are removed and hauled back through the tunnel. It's like gutting a building from the inside until only the skeleton remains. But here's the clever part. The outer steel casing, the massive cylindrical shell that housed all the machinery, stays in place forever. It becomes a permanent part of the tunnel structure, reinforcing the walls and providing extra support. So, in a way, these machines don't just build the tunnel, they become the tunnel. It's poetic in a weird engineering kind of way. These colossal machines designed for one purpose: complete their mission, and then sacrifice themselves to ensure the tunnel lasts for decades. And honestly, it's probably the most practical solution. Trying to extract them would be more expensive and time-consuming than just building new ones for the next project. According to the latest reports, the Jintang Tunnel is on track to be fully bored by the end of 2026. After that, they'll spend another year or so on finishing work, laying tracks, installing electrical systems, safety equipment, ventilation, lighting, all the stuff that turns a hole in the ground into a functioning high-speed rail tunnel. When it opens in 2028, passengers will be able to travel from Ningbo to Zhoushan in just 30 minutes. A trip that used to take over an hour by ferry or car will be reduced to less time than it takes to watch a TV show. And you'll be doing it in air-conditioned comfort at 250 kilometers per hour, 78 meters below the ocean. The real reason China built this: testing ground for the Taiwan Strait Tunnel. But here's the thing. This tunnel isn't just about connecting Ningbo and Zhoushan, it's about proving something much bigger. Okay, so let's talk about what nobody's saying out loud, but everyone's thinking. The Jintang Undersea Tunnel is impressive on its own, but many engineers and analysts believe it's actually a test run for something far more ambitious: a tunnel across the Taiwan Strait. Now, if you look at a map, the Taiwan Strait is the body of water separating mainland China from Taiwan. At its narrowest point, it's about 130 kilometers wide. That's roughly 8 times longer than the Jintang Tunnel. The water there is deeper, the currents are stronger, and the geological conditions are even more complex. It would be without question the most ambitious tunnel project in human history. But here's the thing: if you're going to attempt something that insane, you don't just jump in and hope for the best. You practice. You build smaller versions. You test your technology, refine your techniques, and figure out what works and what doesn't. That's exactly what the Jintang Tunnel is. It's a proof of concept. It's China saying, we can build a high-speed rail tunnel under the ocean at depths that would crush most structures with precision measured in centimeters. And we could do it faster and cheaper than anyone else. And if they can do it here, they can do it anywhere. Now, whether or not the Taiwan Strait Tunnel actually gets built is a whole different conversation, one that involves politics, economics, and a ton of other factors. But from a purely engineering standpoint, China just proved it's possible. They've developed the machines, the navigation systems, the construction techniques, and the expertise to pull it off. And that's a big deal because for decades, underwater tunnels were considered one of the final frontiers of civil engineering. They're expensive, dangerous, and technically brutal. Most countries have built maybe 1 or 2 in their entire history. China's cranking them out like it's a weekend project. The Hong Kong-Zhuhai-Macau Bridge, which includes a nearly 7 kilometers underwater tunnel section, was completed in 2018. The Jintang Tunnel will be done in 2028, and there are already plans for more. China's not just building infrastructure, they're building a playbook for how to do the impossible. Alright guys, that's it for today's video. If you enjoyed this deep dive into one of the most insane engineering projects on the planet, make sure you hit that like button and subscribe to the channel. Turn on notifications so you don't miss our next video, because, trust me, we've got some crazy topics lined up. And here's a question for you. If you could build an undersea tunnel anywhere in the world, where would you connect? Drop your answers in the comments below. I'd love to hear what you come up with. Thanks for watching, and I'll see you in the next one.